What's going on, YouTube? Welcome to my stream. I am Peter Roman. Um, Let me just make sure my audio is working. This channel is named Lorenz Aero. We talk about flying cars, right? We talk about audio's good. Okay. Um, that's my goal is to create a flying car. This is sort of my style that I like. This down here is an AI generated model that I got from images that I took of this right here that I 3D CADed. That has no AI in it. It was all pure grit and determination. Just all of my expertise, I would say, in drafting and CAD, which is what you see here. I'm using CREO Parametric, and I did the first model here. Then I took pictures of it, ran it through like an enhancing thing. That's why they look very similar in style, like that one and this one. And I liked. Here's the reference images. I really like this design, because AI, sometimes you prompt it. It's really just prompt engineering. Like, you prompt it sometimes and it gives you back like not the right thing you're thinking about. So pretty much you can't prompt it to spit this out because this doesn't exist. I invented it. I had to like I had to build that first, take pictures of it, and then tell it to enhance it and all that to get this model. Okay, so I like this model a lot, especially the back right here. This is like the Lorenz style right here. It starts off, the back is gonna look like that. So that's what I'm gonna work on today, is doing the back. The winglets, it goes like up like that, and then there's tail lights here flat, like LEDs and stuff. So I'm gonna add there's actually this one, the one I'm building, in real life, it's gonna have LEDs on it. So just to recap, we have two batteries, four ESCs on either side to power four motors on either side, so a total of 8 motors. Just got the motors yesterday, actually. They're pretty big. They're pretty powerful. Thrust total thrust output from the 8 motors is 50 pounds. And yeah, so let's kind of get started. If you want like a more detailed recap, I recommend watching my first 2 streams that I did on this when I started. But that's kind of like all the updates I have for you guys for now. This is a little bit too wide, I noticed yesterday. So this guy, needs to be 120. Okay, that's what it is. It's 120. I'm gonna try to talk while I CAD, but sometimes, in life, it's hard to work and talk at the same time. I okay. From here to here has to be that divided by 2, and from here to here has to be that divided by 2. So just taking a small edge off of this, because it's not gonna fit. right now. So this is what I did yesterday. I just want to catch us up from what I did yesterday. And then I will be able to continue with the back. But this is the CAD process, you know. It's really just applied geometry, I would say. Let's see if that works. No. Okay, plan B, because that is going to take away my entire sort of progress, and I don't want that. We just need to shave it, you know, from here to here is that number divided by 2, and from here to here is that number divided by 2. Okay. So I am just going to shave this part and then shave this part. I could probably mirror it too, but mirror over this. No, I can't mirror it. I'm gonna have to sketch it manually. Let me just make sure. Yeah, it's a tedious process to build a flying car, but it's my passion. I think the future is aerial. We will all eventually have personal flying vehicles. And I want to contribute to that future. I've been called crazy. I've been called delusional. But that is just the name of the game, you know? Whenever you want to do something in life, people usually have a problem with it or try to discourage you. Not everybody, you know, there are certain people who have like a different viewpoint. But there are individuals who kind of have a different opinion than me on what we should do, you know, in life, like what direction humanity should go into. The main thing I look at when I started this, I was like, you know what? We've been talking about flying cars for hundreds of years. No one's done it yet. No one figured it out. And I think that's a pretty good reason to do something, is if we've been trying for so long to do something, I think it's a pretty good indicator that it's going to be successful on the market. Now that should fit here. Yep. Perfect. That was my main concern. So yeah, let's go ahead and see how this looks. I'm going to work off of the front winglet cabin here. I'm gonna literally just take this assembly, wing front, wing. So let's go ahead and take that guy and save it as a copy for winglet back. And they are wings, so it's gonna provide upward lift during forward flight. This is pretty much an airfoil, if you can see like that design. It's higher on the top and lower on the bottom. So winglet back. Okay. I'm gonna work off of this. So in order to do that, I'm going to need to create an assembly. Actually, what I can do is I can take this assembly and copy. So winglet full mounting back assembly. Associated items. Okay. Winglet full mounting back. Now I'll be able to replace this. First I have to unconstrain everything. So there's probably a way to do that. Like in one button click. But I always just kind of did it the hard way. You know? Okay. And now you could delete this and bring in the winglet back. Okay. So for now, it's exactly the same as the front, but I'm going to be working off of it. Okay. So okay. That's the great thing about my style of design. I like to keep things proportionate. So literally, you can do this. Ready? Assemble, winglet full mounting back, and then just turn it 180 degrees. I had a voting for how to style it on my Instagram, Lorenz Aero. It was either going to be like this, or like this. And we decided it's going to be like that. So if you want to be in future designing decisions, follow Lorenz Aero at Lorenz Aero. Now if I could just, I know that the bottom of this and the bottom of this are the same. And I can literally take this guy and put them on the pipe or the tube here. So okay, that didn't work. So oh, it's like crooked now. That's weird. Oh, you know what it is? Um this guy's not constrained. So he needs to be constrained on the right datum plane like that. Okay, right front to front. And what is this? Top to top. Okay. And then these guys I'm going to have to individually sort of which shouldn't take too long. Maybe like 30 seconds. Okay. That's one. It's yeah, I would say it's kind of like building the real thing on a computer is, you know, there's no physical objects you have to move. So um it is all being done on a computer. Man, this is taking longer than 30 seconds. Sorry, I lied. Okay. Now, when I go back into here, I should be able to mount this and make it look nice. In my opinion, I mean, you know, I think it looks good. I really do. I must say, I'm proud of it. Um, Definitely wasn't an easy feat at all. Definitely was not easy. Oh no. Coincident. Okay. So, moment of truth. This is what it looks like. Or at least this is what we're building off of. Let me just make sure everything's in ship shape. Yep, perfect. It looks like, okay, so this was option B. This is the one we're going with. But if you look at this guy and you rotate him like that, right? Looks pretty nice from the front. I'm not gonna lie. I kind of don't like how it's like uniform. That's kind of, you know, it's like, okay, you just copied and pasted it. But I do like the back a lot, like how it's open like that. I had a I had an idea just to put like a piece of see-through plastic, like transparent Lexan plastic right here, and just have that open up kind of like an engine bay with all the stuff. I really like that idea. So I'm probably going to translate that into, see, like that looks good, you know? I really like that. And I had a debate for about an hour or two about what I should do. And I decided that I like this one just a tiny bit better because I like how it looks like from the side. Also, the practical application to this setup is that between if you walk to the door to get in to sit down in your seat, there's also extra protection from the ducts. So there's that. I mean, yeah, if you're on either side of the Aeroboticar, you know, if you put your hand there, you will get hurt, just like any drone. But I feel like you can put some sort of gate, um, like a grill, around it, and I think that might be what I do, because I do want to take safety seriously. So the first thing I'm going to do is take a measurement of this to this to see how long that is. So it's 6.66 inches. And then from here to here, I'm going to basically just open it up. But I also need to know the distance from here to here. Analysis. Okay, from there to there. And I do need to know that measurement because I need to know where to cut. So I'm going to put a datum plane right there. And take that datum plane. And that little thing right there. From the datum plane to this guy is 0.622870. Yeah. After a while, you start off with round numbers and like prime numbers and all that, like whole, even, whatever numbers. But as you build and build, you start getting like weird decimal places and stuff. It's kind of the nature of design. But I'm going to take this guy. Create a sort of... Actually, I don't think I needed... Well, we know it's 6.6, right? We might not need that other number now that I think about it. 3.33. And then literally, I think you could just open it up. I'm not sure where to place that. I'm not sure where to place that Let me see if I can get rid of this guy. So right now we're just working on the tail right here. I don't know how I feel about that. Doesn't look as cool as like that situation right there. But let me undo that. Well, now I have a decision to make. Do I want to keep that? I guess if I do keep that, it has to be to that wall. So remember 3.33? We need to subtract 0.13 from either side. So it's going to be 3.2. That's better. It had like a little weird wall on it. I didn't like that at all. What is that? XI coupler. I wonder why that's happening. Couplet winglet mount. XI coupler. Oh, okay, I see. Gotcha. So this guy, XI coupler. This one is, I believe, not going to be on the, which is fine. I think that's fine. Well, because this, like, this red part that hooks onto these winglet full mounting couple winglet mount is connected by screws, or bolts I should say, and then this guy will be connected by one coupler, by one sort of clamp. And then kind of just, I think that should be structurally okay. I think that's going to be all right. Okay. So let's get back into the back design here. Another thing that we have to think about is the cabin sort of see how this top part kind of goes into the white part? the red part goes into the white part. I'm going to have to like cut that somehow. But before we cut anything, let's design stuff, because if I cut prematurely, I'm gonna have to cut again after I design what I'm thinking about. Let's go ahead and go here. And I want to create a sort of like, and I'm gonna create like a rough sketch. But if you look here, it kind of like rainbows a little bit, like arches to there. So what I was thinking is that I had it in my head. Let me think what I want to do. Kind of want to create like a curve. Like from this angle here. From this surface. And this surface is gonna sort of have like that, going like that to there. So let's get this guy. Actually, probably more like that guy. And then we need to go a certain height. I'm not sure what height. That's literally up to debate. But it's going to reach down to here, I believe. Yeah, this guy. So what I'm thinking is like a spline. And this right here. And then the height, like I said, is up to debate, so we can just point a finger anywhere and sort of go like that. And then extrude this way, like this. Well, probably not. Well, let's start there. See how that looks. I like that. I like how it like curves into it a little bit. I wonder if I can round this. I can. That's very laggy though, like my computer's working overtime right now. We don't necessarily have to round it, but let's go ahead and check that out, if I like that or not. I like that. That's pretty cool. Would have to obviously would have to chop up or actually sort of bring that down a little bit. So remember the dot that's up to debate, we can bring that down to like a lucky number or something. So now there's more curve, and we're still not there yet. We can keep going pretty much until the top of this line, which is a curve, but the tangent of the top of this line, a local maxima. So we can keep bringing him down a little bit. Okay. So remember when we were at 3.3 and we had that little thing going on, this guy, how we made it 3.2? I think we're going to have to go back to 3.3 and just deal with this little thing going on here when the time comes. But yeah. See, so now it's like on the side of the, it's like hugging it. It's actually a little bit into it. So we have to make this actually 3.34 3.338. Let's do 3.38. So now there's a little bit of a gap, which is what we want. Okay. So the air will kind of travel like this way, kind of like aerodynamically. Just thinking about what it looks like. But we did do some work in terms of all that stuff. We might have to recut, because I'm thinking, because right now it's like very flat, and I don't know if I like that. I kind of want there to be a curve. And that curve should be this guy. But before we do that, let's take this guy's curve. So I believe it's this guy. And we're literally just going to copy and paste it. Left. So we're going to copy this. Okay. And we are going to paste it onto, I believe, here. Or maybe this guy. I think. So rotate, ratio it to 1. And then is there a way to mirror this? I believe there is. Okay. We could literally take all of this, except this. Okay, we don't need this. We don't need two center line. Whoops. We don't need two center lines. Take that, mirror it like that. Delete this part. Okay. I'm liking what I'm throwing. I'm liking it. And sort of extrude that this way. Top. There's a method to the madness, guys. Just hang on. Pretty much to there. Okay. And then let's see how that looks real quick. Okay. That might be a little too far. Not gonna lie, I think we're gonna need a cut from about right here, this line, and we are gonna angle it like that. Like that. So let us go, create like a line like that. Okay, let's go from the top. Okay, I need to see from here and then probably to about here. Or no, maybe here. I think. I think that's good. Top. And now I'm going to sort of take a spline and curve it like that. And then take this line to here to here. Actually, it's going to need to be from here to here. Like that. Yep. Like that. What does that do? It doesn't really do anything. It just gives it a sort of you know that line that we copied and pasted? I kind of want it to match the curve of this guy. So if we go back to here, So we can literally move this way. No. There's no measurements for curves, so I'm gonna have to do my best to guess. But if I had to guess, it would be probably something like this. Like that. Let's see what that does. And then this guy, we're gonna have to redo all that. So pretty close. Pretty close, just a tiny bit off in terms of direction. 1.46, about 1.5 inches. So this guy, yeah, this sketch, we can do minus 1.5. Something like that. That looks pretty good. And kind of want it to have like this sort of, see this picture, how it has like a curve like that around. So I want this from here to here to extrude as well. And then I'll literally cut like that and then into the, so this needs to get extruded. Spline, 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 spline. Like that. And straight down. And then here. Okay. And now extrude that this way. Probably to like the halfway point of the circle. So wherever the top is. So it's going to be like, when does it start going down? Up, 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 up. Flat, 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 down, down, down. So it's about like right here. Doesn't have to be exact. And now I need basically a curve like that. Like that. Okay. Then like that. line from here to there. I think that might be too... Well, I think it goes something like that or so. How does it go? It's kind of just a straight line from here to here, maybe a little bit curved like that. And then you're going to get rid of this guy. This little... Okay. Extrude that. See what that looks like. I kind of like it. It's a little heavy on this end of things. Could probably... It doesn't have to be this chunky. It's kind of supposed to be like a wing type situation. Because right now it's like... Well, you know, I do want it to be kind of like a wing. Because aerodynamics and stuff. What do you guys think? Does that look similar or no? It kind of like... We're definitely not done, but... Trying to think like... I think that's pretty good. Not even gonna lie. This little thing right here might be a little bit obnoxious. Like if air is just gonna like kind of vortex in itself into here. I'm wondering why it didn't like this guy. Oh, it got like messed up here. I think it's supposed to be like that. Oh, okay, there you go. I was like, why? Okay, so that gets rid of that problem. The little air thing that was happening. Yeah, curves are hard to make, man. But here I am making them, you know. Well, here I am. I'm just thinking like I do like that. I'm going to leave it like that. It's probably going to have to get hollowed out a little bit cuz the 3D printer, it's a chunky piece. So I'm going to have to hollow it out a little bit when I get to that point. And what am I going to do about that, though? You know what I can do is sort of go to the cabin. Take this guy, sketch on him, because we're gonna need like a place to mount, you know. So I'm thinking something like this. Point three. I think it's 0.333. Is it 0.332? Yeah. Okay. Let's see if that helps. So now we don't really need this guy. This guy. This guy. Let's see how he looks from the left or the right. That looks like an airfoil, right? Yeah. It's a big ass airfoil. But I wonder if the angle of attack is like this, right? If it's pitched forward, traversing from whatever from whatever position into the positive direction, the forward direction, forward flight. If it's angled, because that's how drones, they angle themselves to go forward. And then the air kind of gets pushed this way and they get thrusted this direction. I wonder if an airfoil like this will cause it to fall to the ground or lift it up. No idea. But let's go ahead and create a datum plane here. Sketch on it. And then sort of all of the information in the X or the Y needs to be translated like so. Maybe like that. else has to be cut? What else has to be cut? That could stay. That's pretty much all that has to be cut. Okay. Remove, and now if I remove the material this way, it shouldn't do anything on this side, which is good. And then I need to take this, mirror it over this. Huh. Okay. Then we're going to do the same on the x-axis. So a line here, a line here, a line here. Half circle there, a line here, a line here, a line, oh no. I don't think that's a half circle, is it? I think it might be actually. What else would it be? Okay. Okay, so now extrude in this direction. Actually, this is gonna be tricky actually. Gonna need to make like a rectangle around this. Extrude. Remove material all the way to here. Mirror that. Now we have our shape, and then we can sort of create well, actually we can create we can sketch on here. I probably didn't need to do what I just did, but what are you gonna do? Then from sea to shining sea. This guy. Okay. And then from here to here. Okay. I guess I'm kind of just drawing in 3D. That's really kind of what it comes down to. I have no idea if I'm doing this like the way someone else would do it. But this is just the way that I do it. I could date 100 E's many times. Won't get my password. And then finally, we just have to get rid of this guy. By creating a circle. Why did that get left behind? Guess I have to get rid of that too. And then just extrude it downwards. Excuse me. Okay. Now this should be able to fit. It fits there. There's a little thing going on here, but for 3D printing purposes, that's honestly not a bad thing. Oh, and then one thing I did need to do still is sort of create like extrude that way from here from this guy. So basically, I need to get rid of all of this like that, but I need to make sure that I am respecting this guy, this character right here. Where is it at? Is that it? Nope. I need like this guy. Maybe here. Oh, yep. I found the hole. That's what she said. Why would she say that? I don't know. From here to here. I'm kind of blind right now. I don't know. I don't know if it's. You know what? You know what I'm gonna do to make things easier? I'm going to cause this to go away. Extrude. Oh wait, no, no. This way. Okay. And now we can freely print on sketch on this. So we need this guy. We need this guy up until here. We need this guy up until here. And then we need this line to here, this line to here, and then get rid of all of this right here. Wait. Get rid of him. Get rid of him. Get rid of him. That. This guy. This guy. This guy. These two lines aren't connected. I think I'm just gonna mirror this. This guy and this guy could just mirror him. Like that. Okay. And we need to get rid of all that. Remove. Oh. Okay, I think that's fine. And now and that is pretty much it, I think, for the back. this. There's a gap there, so the tolerance is good on that. That fits here. The holes align. And all that. So all that sketching we just did, pretty much, this is the end result. Okay. So now we have to copy it to delete this, bring this guy back. Oh, wait. This guy needs to be like this. And now we kind of just need to copy it all over to this side, which is really simple. Copy this. And I think I don't think we need that. We do need this though. And we do need that, I believe. Okay, so mirror over this. And now that's kind of it. Except this isn't perfectly this is supposed to be let's see if we can fix this. Because it's not flush with the bottom of this guy. So let's see if we can. This might break things. Because there's a lot riding on this. So this might not work. And I might just have to live with it. But I'm hoping that that's not the case. Nope. I'm tired from today, I'm not gonna lie. Did a lot today already. Let's see if this works. That's why I'm kind of not talking right now. But hopefully this doesn't break anything. And it did break stuff. It definitely did. So let's undo that. And I think we're just going to have to live with the fact that this isn't. Or you know what? No, that'll increase the gap. I could probably sketch this guy. Right? Okay. Sketch this guy. Go like that. Go like that. Why did it delete the entire circle? Did I ask you to delete the entire circle? No, I just want these lines deleted. I guess, numbers don't lie, Pete. Numbers don't lie. What can I say? What can I say? What can I say when I see your face? Let me stop. No, continue. What were you saying? What can I do about you? 0.11111. Honestly, that will have to do. So now it is flush. And all I have to do is mirror it. Cross that guy. Do you guys get secondhand embarrassment? Okay. I asked because someone told me they get secondhand embarrassment. I was like, bro, how are you like an empath or something? Everything's uniform now. Everything's evens. That's pretty much the back. That's it. That's how you do it. Let me take a sip of my coffee. Okay, now let's watch the cabin unfold. Okay. I see the vision. Let me just delete these guys. Remove material. Okay. Nice. Nice. Where is... Oh. I was like, where's this guy? We need to mirror him because we did not mirror him. Okay. appreciate you if you're watching right now. I really, really do. I could probably hollow this out so that it's not so, like, create a shell. Um, 0.03. Nope, not gonna work. I was gonna like cut, like shell it out, hollow it out so that when the 3D printer, I wonder if I can hollow it out this way. Nope, I can't. I could do infill like 20% or so. That's gonna be a very, very. That's a lot of plastic to be printing. You know what I could do though? That's a hefty. Wow. That's gonna be a lot of plastic. I wonder if we can sort of. Does that look sort of like that? Like from the back? There's like this thing that goes down that I really like. Yeah, I mean, this is going to be an expensive machine, an expensive robot. I plan on getting the Jetson Nano AI computer so that it's can make decisions with video inference. So this thing is going to have AI on it. And it'll be able to like track you, follow you. It's going to be able to map out like the inside of a building and self-navigate through itself through it. We are a long ways away. But this is sort of the shell. Okay. This is more than a shell because it has a lot of the electronic components already. I don't want to get too ahead of myself and go ahead and like tell you that I can start printing or whatever. But where do we go from here? Cuz I like this back like engine bay sort of view from the back that you'll be able to see and just kind of look through. That's really cool. Chef's kiss. I'm gonna put like a Lexan plastic right there and just like freaking it's gonna look sick as excuse my language, but it's gonna look absolutely disgustingly awesome. I'm trying to look because in here there's gonna need to be an anti-spark switch, a here link, 2 circuit boards, 2 power distribution 5-volt circuit boards. Actually, probably not. There's gonna need to be a mock HYB BEC. So basically a buck converter or a voltage step down, sort of. It converts the 22 volts into 5 volts so that the big ass battery doesn't fry the electronics, especially the Pixhawk, the HereLink, these guys, and the HereLink air unit that communicates with the controller, the receiver, and the transmitter. And it like you can put a video camera. I'm gonna attach a FPV camera that attaches to the HereLink, which also needs power. From this guy right here, I'm putting power on this for all my 5-volt, including my Pixhawk, my FPV camera, um, and a bunch of other stuff like the here link, um, the Jetson Nano is also there. Actually, there is 2 power bridge distribution boards. So, LEDs. Okay, what else am I missing? 2 anti-spark switches. I have the here. Don't go away. I'm gonna grab my folder. This is the layout. This is kind of the system's design. So, a Pixhawk Power 2 backup, um, a redundant battery system. So if battery 1 fails, battery 2 can take over and still fly. HereLink air unit, which is connected to an FPV camera, which needs its own power. LEDs, a LiDAR rangefinder. There's going to be a sensor on the bottom, probably in one of these holes right here, that will be able to measure the distance from the drone to the ground very precisely, like 10.42 meters. I think it's two significant figures or 2 decimal places. Um, and then there's going to be a separate circuit that has a different buck converter, the Tubson buck converter, and that powers the Jetson Nano AI camera. So let's do this. LiDAR, we could do either FPV camera, because we have the here link. Okay, so the here link's right here. I don't know where to put that yet. I have to figure it out. I don't want to make any holes for these guys yet. Pixhawk and GPS already have a sort of home to live. Okay. We could do a bunch of stuff. We can do we could do anti-spark switches. We could do the Tubson buck converter. I think I'm going to start with that. The Tubson. The only thing is, for a lot of this stuff, I would need to buy it and then measure it and reverse engineer it. So I think I've hit a wall for the amount of stuff that I can kind of do, because I don't think the Tubson buck converter Tubson 15 amp I think it's this guy. 22 volt to 5 volt 15 amp 75 watts. So unless they give me the dimensions here, I don't know what to CAD. You know? Like certain things I need in real life to measure and then reverse engineer. I can guess, I guess I can guess, but we can try to check the Jetson Nano. NVIDIA Jetson Nano Orin's one of these guys. The only thing is I don't even know which one specifically. Orin Nano Super whatever. Specifications. Let's see if the data sheet has the 103 by 90 by 34. Height includes feet, carrier board, module, and thermal solution. So I don't know what I have to talk to AI to see. I have to talk to like either Google Gemini or ChatGPT to figure out exactly which one and what purposes and all that, like what I need, which will also fit on the battery system. And then I need anti-spark switch, 2 anti-spark switches. I believe it's this guy. This guy. If they have the specifications for this, which they do, we can CAD this out. 60, 16, 45. So let's do that. New part. Flipski anti-spark switch. So anti-spark switch. This is in millimeters. So let's do part solid ABS. This guy. And it's just a very simple cube or a rectangular prism. I think that's what rectangular cubes are called, right? Rectangular prisms. So this is 45. 45 divided by 2. This is 60. And this is 60 divided by 2. Okay, and 16.5. What color should we make it? It's like a black color. So let's just stick to the true reality of what the situation is. Save that, and then we could add that to our model somewhere. And that's kind of what I have to figure out, is where do I want to put it, if it will even fit. But like I said, there is a lot of room in like the skyscraper. Like if I put it, for example, on this wall, and then it's going to be kind of in the trunk situation. Okay. So the anti-spark switch and all that comes after I make sure that the frame actually takes off. I'll be able to come back and rewire all of this stuff and add the sort of cabin and the winglets and everything like that. But this trunk, which brings me to my next point, which is that if I want a trunk to open up, in order to click the anti-spark switch button to turn on the Aeroboticar, any questions? Any questions? You guys have any questions? The only thing is, there's a wing here which is going to contain these guys. You know? I guess I can do something like that, where it like, you know, because I'm going to need to open the trunk, and the wing is part of the trunk, but the wing also contains these HearLink antennas. So it's going to look a little funny, but I really have no choice because I already decided that I have to place them here. You know, technically, I guess I could put them sort of like this, like on the side of the car, like that. That could work. So that way I can open the trunk without having to worry about I'm like, you know, cutting the wires or moving the wires around or something. It's not connected to that. The only thing is, I believe these have to be at a 90-degree angle to each other. So that might be a problem. Might be. That's why I had them on the wing, because that's why they were at 90-degree angles to each other. But irregardless, I need to design the trunk. The trunk and the frunk. So create an assembly cabin full. Actually, just cabin. Lorenz. And assemble cabin. I apologize for the noise. Someone's vacuuming in my house right now. Okay, so the cabin is that, and then I'm going to need to open the cabin, create a copy of it called cabin hood. Okay. Cabin hood. And where do you think it should open up? I think it probably should open up right here. So we're going to need a sketch on here. Where's the sort of the spline situation? Oh, right there. Okay, so all that. So about there. It doesn't have to be a perfect science. It just needs to be sort of functional. Okay. And then we can literally delete everything else. Okay. Extrude. So that will be this will be the trunk hood. It does cut off a little bit here, so let me I want to make sure that it's like that. Okay. Okay. Let's see if that worked. Yep. And now we need to take this sketch and make sure that we can align it properly. So for example, this and this, we can do it on this corner right here. Create a line. And then go like that. And then we could actually pretty much do it like that. Okay. And we need to copy this guy. Okay. And then go to cabin. This. Sketch on him and then paste it. Ratio is 1. And I think you can literally place it, place it right on the, right here, 0 and 0. And it will find the appropriate layout. But now, instead of deleting this part, we're going to need to delete everything but the wing. Okay, so now instead of going that way, we're going to go this way. Okay, so delete that, delete that, delete that, delete that, delete that. Okay. I mean, not everything but the wing, but just the wing. So remove. Okay. And as you can see, it left over some stuff, which is okay. We just have to kind of dot our T's and cross our I's, which is well, that's the hood. That's the trunk, I mean. Okay. I see a way out. Here, 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 here. And now just extrude and remove material. Okay. And now this little, I don't like how there's like this little edge right here. This like little thing going on. So I am just going to create a support, like a structural support for it. Extruding out this way. I'd say maybe like 0.4. Okay. And now, cabin hood. Oh no, I should have said trunk, not hood. I should have said cabin trunk. Save as. Save a copy. Cabin trunk. Cabin trunk hood. Open cabin trunk hood. Save that and then put that into the assembly. So that's the sort of thing. And this is cool. Watch this. Cabin trunk hood. See, now we have the hood. We just need to constrain it. Center it. And now, you guys see that? How it like opens up and stuff? Pretty cool, right? Pretty cool. I'm gonna need to create a hinge. How long have I been streaming? Okay. I'm thinking like I'm gonna need to use screws and maybe a sort of a one of those, what are those called? If I want to create a hood for the Aeroboticar trunk, what is the best idea for a hinge, given that I am 3D printing and maybe want to use some sort of pin mechanism? This one actually does have a hinge, like the trunk does open, but it's very not robust. I kind of just did willy-nilly. Hinges are a topic, I'm telling you. It's a whole study of how to make hinges. The first time I encountered making a hinge, I was like, oh, this is going to be easy. And then I started thinking about it. I'm like, wow, hinges are actually... But it is a pin. Like, you need a pin of some sort. Let's see what Gemini says. I'm probably going to have to sketch a little bit, but you could probably just do like a door hinge thing. How they, like, you put a pin through, or you take the pin out, but you connect the two like holes together, and then you put a pin in it, and then it opens up. And then you need like a latch so that it doesn't fly around and flop around and stuff. That's probably what I'm gonna do. So let me go. Let's see what you must print orientation. You must print your hinge halves part A and B flat on printer bed. The round barrels should be standing up so the pinhole is vertical like a chimney. This ensures the printed layers are not taking the shear force of the hinge, which will prevent the barrels from snapping off. When you model this in CREO, tolerances are everything. This is the gap you must leave between the moving parts to prevent them from fusing or grinding. Pinholes versus pin. Your hole must be larger than your pin. For a 1.75 millimeter filament pin, model the hole in your barrel at 2 millimeters to 2.2 millimeters. The pin, your best option. A metal rod or nail, a piece of 1.75 millimeter filament. Bad option. A 3D printed pin, it will be weak. It will be weak, brittle, and will break. How to design in CREO. The hood hinge. This part will be 3D printed and will attach to your white fuselage. It will have several barrels, the round parts, with a hole through them. Let's say it has 2 barrels. The body hinge. This part will attach your internal chassis. It will have a barrel that is designed to fit between the 2 barrels of part A. The pin. This is the simple metal rod that slides through all 3 barrels to lock them together. Interlocking barrel hinge with metal pin. So that's exactly what I was kind of just saying. Like a metal pin like that. Thinking like something pretty strong, you know. Maybe 2 or 1 long piece. Thinking maybe 2. Let's see what Amazon has. You gotta design around the supply chain. Maybe these stainless steel dowel pins. So maybe something like this. 3.9 star review. I wonder why it has so many 4-star reviews. Case was broken. Okay, non-issue. Broken case. Excellent quality stainless steel, but all mixed up in shipping. Don't care. Awesome for 3D printed parts. My only complaint is the organizer isn't the best made. Don't really care about that. Affordable, high quality dials. Very clumsy case. Okay, so literally I'm going to be having to expect a broken case because literally everyone is saying that it's broken. But that's really not really a problem. Let's see if there's neater ones, because I don't want to deal with that. Maybe this one. This one has 4.5 stars. That's a little bit better. That's a lot better, actually. Yep, all 5 stars. Their dowels, they're smooth, clean, and dimensionally accurate. Okay. Yep, look, this guy is saying they're being used as hinges for a door. They fit perfectly and work exactly as intended. So I'm going to add this to the cart. Add to cart. And then I have to add that to this is my supplies Aeroboticar. You have the price right here. It's going to be $1,196 so far. Plus this, which is how much? $12.99. Plus $12.99. So I'm just going to add that to the total of $11.96 plus 16 plus $12.99. So new total comes out to $12.09. This isn't even everything. It's gonna probably be $3,000 to $4,000 total, because I have the Pixhawk, the Here Link, the Here 4 GPS, the Mach back, the Mach PL sensor, the XT30 connectors, the M2 screws that I didn't even add yet. So, yeah. Okay, so let's assume we're using a sort of M3 pin. We could probably use actually I'm thinking maybe like an M5X25. So 5 by 25. 5 by 25. So new model, hinge pin, Lorenz, millimeter part solid ABS. And then we're literally just going to go from the right hand side, M5, so a 5 millimeter pin multiplied by 25, I believe it was, millimeters. Does that look accurate? Yep. And then add it to the cabin. Let's see if it's to scale. Hinge pin. Let's go here. And it will be sort of like a pin. Kind of like that. So this will sort of need we'll need like knuckles or whatever they're called. What are those called? Uh is this inches? Yeah, I think that's inches. So we need something that's about I would say 7 millimeters to inches. 0.275. And then create a like a pin sort of I guess it would be it might be have to be longer than 25. What's the longest one they have? We should do like M40. We should probably do like so it's more robust. You know, we should probably do 40. And that will give us a lot of grip strength. So sketch on this. And let's see what's from here to here is what's 40? 40 millimeters. 1.5748. From here to here is okay. So that will be sort of the pin length. which means I want the line to be onto here though. Can we do that? Just so it makes, sense and all that. What's the distance from here to here? It should be equal to or more than 1.57 from here to here. Okay, it's not giving me an accurate measurement. 1.77. Perfect. So now we're going to need to create like I would say 2 slots. Where's the center line? What? For what? So the center line is going to be right here. No. Yet. Center line is here. So I'm going to say I'm going to create 2 lines here and here and here. And then I'm going to delete this, 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 and this. And this stuff. Okay. So those will be our notch pins. Okay. And then a 5mm sort of thing needs to be let's see, 5mm. What's 5mm? 0.19685 inches. And from here to here is going to be about point 0.15. No. From here to here is 0.15. No. Oh, because this guy. 0.15. There you go. Actually, 0.2 is probably more sturdy. Do you guys think that's pretty thick, right? And then the distance from here to here, 0.15 and 0.17. So let's do 0.16. Okay, so they're both 0.16. 0.2, 0.2 times 2. So let's actually extend this out this way. 0.4. Okay, and now we can extrude this guy. Remove. Okay. And now we can go into our pin. Actually, not yet. But we can mirror this guy across here. And then I'm thinking you could probably put the pins in there. So we need to basically copy I don't know how sturdy this is going to be. I think I need to extend this guy. Remember how I said we need this guy to be like robust? We're probably going to need to do like 0.78 or something, so that the hinges have some sort of structural support. This is a little questionable here. The roof is kind of like just sitting. That's questionable. You could probably I wonder how that will print, you know. But let's see. So let's take this entire guy. Okay. And then put him on this guy. The thing is, I don't know where to place him. I might have to do it manually because I have no idea where. What is causing this? Am I still sketching on something? Oh, yeah, I'm sketching here. Okay. I need to take some measurements for what I just did. this guy. He's always trying to hide from me, man. Okay. Let's see. So from this corner to this line is 1.17. Okay. 1.17. So from here to here to somewhere over here is 1.17. And then let's open this guy up. From this end to here is actually, I think there's two lines. Hold on, let me make sure I'm grabbing the right line. From here to here is 0.40913 for some reason. Okay. Okay, so from here to here is 0.40193. And then how big is that box? You probably want to give it some tolerance. So I'm going to go inside a little bit and create a box like so. 0.39. Actually, it can't be smaller. It has to be bigger. So 0.4. Let's scratch that. I'm doing the tolerance for the wrong thing, I think. So from here to here, here to here. And then model and that, extrude, remove. And then I also need like a 5. Well, I need a pinhole. Need a pinhole for it. I just don't know like where to put that. You know? But let's start there and kind of guess and check our way to success. I'm a guess and check kind of guy, you know, brute force method. And I kind of want to see some progress. So if we put the pin, just to show you guys that we are making progress, because this is taking forever, but you put the pin on this axis right here. Okay, slide it through like that or so. Then you put this guy on the pin. Okay. You line it up Oh wait, so this I think I put the hole in the wrong. I put the hole in the wrong place. But that's kind of the idea, is that it's gonna go like that. Pretty cool, if I may say so myself. Um, I just have to move the hole over a little bit. This guy and this guy can be constrained. Um, Let me just figure some stuff out. Let me look at this for a while. Not too long, but whoa, whoa, whoa. This guy, not the other guy. Okay. Oh, there's a problem actually. I shouldn't have this guy right here. This guy needs a little bit of this. Extrude 12. What outdated references do I have? Okay, there you go. Okay. Extrude this guy. And we're gonna have to start all over. We can get rid of all this. Okay. But this guy, how do I update the reference on this? I think I have to right click. Properties. Cancel. You know what we can do is just create like a rectangle. To here. And that will kind of be our hinge structural sort of support thing. Okay. And this guy, now when you bring him in here, he should close. This is really difficult, man. This is not working. Oh, it is working. Huh. Okay, that does work actually. So we sort of need like a measurement from this wall to here. What is that? Let's just write this down. 1.7. Second time's a charm. Am I right, guys? From here to here. 0.409. And then from here to here is this number. And then from here to here is 0.2 inches. So I need these four numbers to make a good decision. So let's go ahead and sketch like that. From here to here is, it's gonna work this time. I think this number. What is what does that have to do with anything, bro? What the? Okay, let's just create a line instead of doing all that. From here to here is 1.7. Okay. And then this is the mount, so it's going to need to be a little bit bigger. Okay. So this is going to need to be 1.15. And then this guy is going to need to be, I think we agreed on a perfect square or something. But okay, 0.42, because this is the, okay. Let's see if that is enough. Okay. Oh, because I keep making holes. Keep making holes, bro. Instead of need to make a hole for this. Plus 0.409130. As you can tell, making hinges is pretty difficult. But I think we accomplished our goal. We could probably make this like 0.45 or even like 0.5. Let's see if that worked. What is this from here to here? 0.0587. So increase this a little bit. Okay. All right. Very tedious, but I think we got it. Ladies and gentlemen, I'm not gonna be gay. I'm not gonna be gay. And then we just need to mirror this guy. I was gonna say, ladies and gentlemen, we got him. You know that Bill, what's his name? Bill, George Bush. When they captured Osama bin Laden, and there's like a whole meme, and he was like, "Ladies and gentlemen, we got him." That's how I feel right now. We could probably create like I don't know. How are we gonna get the pin through here? What's this? What's the size? We need to get a pin all the way through, but once I get it through, I mean 0.5 millimeters, 5 millimeters to inches, or no, what was the size of the 40? 40 millimeters to inches, 1.57. What is this length? 2.5 inches. That's not enough. I'm tired from today, guys. I think I might end the stream. 25 more minutes. I kind of want to get this done, but I feel like maybe I'm messing up because I'm so tired. What is this length right here? 1.32. So the pin can fit here. I could kind of cheat right now. It wouldn't really be cheating. I would just have to make the holes a little bit bigger. But what I could do is I could I could literally get rid of like this whole thing right here. So instead of it being right there, it would be what did I even just do, man? There's like way too many center lines going on. We don't need this one. And we don't need this one. We just need a rectangle that goes from there to there to there. And then delete this. Okay, there we go. See, so it'd kind of be like that. And once the pin is in there, bro, the pin is freaking in there, bro. It's never coming out. So that's not good. I would need to create like a little notch right here as well. Man, creating hinges is freaking difficult, bro, because now I have to know. I'm just tired. I'm not feeling it today, man. I went through something today, bro. You know? And you're forcing me to work. You're forcing me to work on my day off. 1.715. You know what? This number minus this number 1.5748. This is the magic number right here. 0.1402. Wait, what number was that? From here to here. From here to here. Sorry, 0.803 minus. Wait. No, it was 0.83 times 2. 0.83 times 2 is. What the hell? 0.83 times 2. 1.66. This is not making any sense, man. I can't even think right now, bro. But I gotta force through it, bro. I gotta force through it. 0.83. What is this from here to here? Oh, it's from this to this 1.715. Yes, because the pin is gonna fit in, so we need to measure from here to here 0.1402. From this center um, from this center to over here is 0.1402. Okay. And then we mirror that over this and create a line and another line. Okay. And that should be pretty good. And then you could put pins in there on either side, but this is my first time making a pin hinge, so excuse me if I'm not doing it really good. Those holes I want to keep, but this hole I feel I need to create a hole here, but this hole needs to be the same size as this, which is 0.44250. Point 44250 minus 0.287. So it needs to be that much bigger. Plus this divided by 2 plus this divided by 2. Okay. So now they're symmetrical. And then what I need to do is create. I wonder if I can get one long pin to just go right through it. Cause like, I'm almost there. Let me get rid of this. And then I need to make teeth. Not teeth, but gaps for these guys. So this guy is how big? 0.608. And how far away is the center of that? I guess we're just gonna guess. Stop. Stop doing that, man. Get off of me. Why are you doing that, bro? I don't know. .608. And I guess we will sort of just guess and check our way into success. But he's gonna need to go that way a little bit. .38. Okay, that's actually perfect. But we need these guys to be a little bit smaller. So these gaps need to be a little bit bigger. Like that. Let's see. Yeah. This gap could probably be a we could probably undo that. Oh wait, no, not that guy. This guy. Where were we? Which gap did we just change? I think it was this guy. Cause I don't know if I'm creating teeth or if I'm creating what am I, like gaps or teeth? I don't know. That's pretty much the best I could do. And then I would need to create holes for this guy, but I don't know. I have no idea what to expect. Sometimes I just say words that like yeah, that come to mind without really thinking about if they make sense. You know? Do you guys ever do that? Or no? Oh, I think I got it. I think that's literally it right there. Oh, nice. Okay. So yeah, there's tolerance. There's tolerance. There's tolerance. I just need to create like a hole through here. And then I need to find a way to create like a hole through, like a notch here. And then put a pin. But then there's going to be like a hole through the cabin type of situation. What do you guys think? um, there's definitely gonna be a hole in the cabin, and rain's gonna get in. Like if it rains from the bottom here, there's gonna be a hole here because I don't know how to get the pin inside unless I just got a very long pin. Like how many inches is that? I think it's like I think it's literally 6.67. I wonder if I can get like literally 169 millimeter M5 pin. I don't think they make 165 millimeter M4 pin. You know what I could do is I can 3D print something that pushes it in. You know what I mean? And then I could do that from either side, and then we'd be golden. And sort of create like a what are those called? Like a wall, so that it like a lining wall, so that it like when you push it in, it stops at the wall. Okay, and then that's how you know it's securely inside. So that wall I'm talking about would be around here. So you can literally insert it from there, push it all the way through to the wall, and then the pin would kind of be stuck there. The only problem is if I ever, for some crazy reason, want to um, replace the pin or something, I would have to create. The solution around that is I would have to create, when I'm 3D printing this, I would have to create this as this hinge as a part that attaches to the trunk hood thing, the trunk like flap, whatever this purple thing is called, and then I would mount the hinge onto it. So if I want to remove the hinge or remove the door, I would remove the hinge, and then I would be able to remove the whole door. Genius. I'm a freaking genius. So let's go ahead and get the dimensions, the hole placement for these guys. Which is this right here. I would have to sketch on this guy. And then just get dimensions for him. So from this corner to this corner, this edge to this edge is 0.2. And from this dot to here is, from this dot to this dot, oh my god, not the angle, is analysis. Huh. How is it 0? That's what I don't get. I'm pretty sure it's 0.2. I think it's because this is not a parallel line. This is not a perpendicular line. So I need to make this a perpendicular line. The only problem is it locks onto this curve right here. So maybe take this curve to this, or this dot. Um, huh. How do we do this? We can do it from the top. Let's see if that works. Why get rid of the center line? Point analysis. 0.157460 from the top. 0.1, and I think I copied it. So go like this. So it's 0.2 from here. And 0.157 whatever. And then probably like a 0.52. 5.2 millimeters to inches. 0.204724. Let's do that. Okay. And then I would have to create. The only thing is, how is this going to 3D print? Like I said, I'm going to create like a hinge. Like the hinge is going to be separate from the hood and the cabin. And then I'm going to print it out. It's probably sideways or something. Like so the pins are standing up like Gemini said. And then I'm going to attach the hinge onto this area. So I'm going to need to sketch on this guy. And then create like a wall sort of thing. Okay. Extrude. So you won't really be able to see it, but as you can imagine, there is like this thing. See how there's like a wall right here? So right now it's hollow, like that one. Like that one is hollow. But now there's going to be a, let's say, I don't know if that's inches or millimeters. But I would say probably like 0.1, 0.09. That sounds good. Is this inches or millimeters? I think it's inches. 0.45. Okay, and 0.09 is 2. That's plenty. So now when you put a rod through it or a pin, right, you'll be able to see the whole way through. And then this hinge pin will sort of be on here. And then I'll create like a mechanism that pushes it all the way to the wall. Whoops. So I'm going to take this guy, this pin, and push it all the way into the wall right here. And so it will kind of be like that. Okay. I wish they made longer pins. 5mm pin. What is it called? Metal pin? Metal pin long. 60mm from Harfington. Extra long shelf pins. I see 60mm. 60 should be okay. I'm gonna add this to cart. 60 should be perfect, actually. Oh, I have 40 right now. So imagine 60, brother. I think we're in business, bro. Yep. That's exactly what I wanted. Let's go. So now it's supported by this, this, and this. Okay. So now when you, this guy, so now when you open the cabin trunk, let me just constrain him so this looks pretty good. Okay. And that's sort of what it will look like right there. Okay. However, the last thing I need to do is curve these edges, because as you can see, these intersect. So the fix for that is curving these guys by like 0.16 or so. If it actually works. Yeah. Okay. And not only curving that, but also curving this guy. Okay, rounding that out. Paint it white. It's white because that's what 3D printer material I have. I guess I could use black or red, but it's just the brand colors, I guess. And now, yeah, I think there's a gap there. You guys see that gap? There's definitely a gap. Oh, and this guy needs to get curved. This guy, that, and that. And then here, that, and that. So now, when you open, let me just paint it. So now when you open this guy, yep, perfect clearance. Let's just make sure. And then when it's down, there's still a gap. If anything, it will kind of just add like a sense of, you know, not torsion, but yeah, you get the idea. There you go. So now paint this entire guy. Okay. And now we can add this cabin to here. So that's the situation. So let's go ahead and delete this. Actually, we can't. We have to replace it. Insert here, or replace selected component, because it's a lot of things are constrained to it. So assembly containing the model. Remember these components. Don't remember. And then cabin assembly. Yo, did we even save cabin assembly? No, we didn't. Okay, now we did. And take this guy, replace him. Replace select component. Do not remember. Assembly containing cabin. Apply. Okay. There you go. That's sick as fuck. So now it has a trunk. I would just need to create a latch for it. That's pretty cool. Gotta admire your work, you know? Definitely. This is the anti-spark switch. So now when you open the trunk, you'll be able to press a button. You'll be able to press a button that starts the battery. I think battery B. And then we would need to create a whole separate mechanism for the front, but I'm not going to do that today because we're already streaming for 3 hours and 10 minutes. And it's almost bedtime. It's almost 6. So close it. Okay. So it closes. We can move this guy. That was a lot of work. 3 hours, that's $150. $150 for all this, I would say. Like to create that hinge. I don't know what else I did today. I did this as well. So this and this is $150 that I just did. If I had to pay someone, if I had to hire a Fiverr engineer, like someone from the internet, like Upwork or something, they could easily charge me $150 if I sent them all the files that I had before, told them to make this. But you know, defining the problem is half of the solution. So just being to explain what you want, you're halfway there. Now you just have to like apply that constraint to what you want, and you get this right here. So there's the trunk for it. And then I'm going to create like a platform for the anti-spark switch somehow. And the button that you actually press, you press a button. So you'll probably be able to reach your finger through here, press the button, or open this and press the button. But there will need to be a latch, like here and here, so that when you close it, it like physics kind of takes over, and there's like a little knob and a little female end to the knob, so that when it closes, it like sticks in. And when you want to open it, you kind of have to like dig your finger in and like open it. That you can kind of do without any like fancy pins or any like it just needs to be secure enough so that when it's flying around, it doesn't, you know. But I'm gonna end the stream there. Just doing like one thing at a time, you know. I did 2 things today, but I didn't feel satisfied with the rear winglet. So I'll let you guys go. Thanks for sticking around. Thanks for watching. Hit the like and subscribe. I'll see you guys